Good evening, guys, and welcome back to the second or third part of Chapter 2, Lesson 5, Equations and Problem Solving. Please make sure you have your note-taking guide in front of you, and we are going to be on page 39 in this video. We're looking at a situation where we have two objects going in opposite direction, and remember that these are distance rate problems, and from the previous video, hopefully you remember that distance equals the rate or speed that something is going times the time it takes for that object to arrive. If I multiply my speed by the time it takes for me to arrive, I'm going to get the distance covered. And I can use this to solve some pretty cool equations. Let's look at a situation over here. I have two jets leaving Dallas at the same time and flying in opposite directions. Notice they've left at the same time, and they're going in opposite directions. One is flying west, 50 miles faster than the other, and after 2 hours, they are 2,500 miles apart. I want to know what their speed is. Okay, so I'm going to take my highlighter and I want to really highlight what I'm looking at. I'm looking to find speed. So if I'm trying to find the speed that each jet is moving, I need to have that's my R over here. So if I need to find my speed, then hopefully I know distance and time. Let's see what we've got to work with. So I need to define my variables. Let's look at this. I'm again going to end up using this formula here. So I have my distance traveled, and I have time, and I'm hoping to find rate. Okay, but remember that for each of these items, I have two separate sets of information because I have two different planes. I have this guy who's going east. We're just going to write the eastbound here. And then I've got this guy who's going west. Okay. And let's come back up here and let's see what we have. I want to find speed. So if I want to find speed, I can either use R as my variable, or as your book likes to do, I can just simply say x equals the speed of a jet. Now, which one am I going to be talking about? They're leaving at the same time. One is flying west 50 miles an hour faster than the other. All right, I'm going to take the one that's just going the normal speed. So which one is flying at the normal speed? The eastbound jet. So I'm going to let x be the speed of my eastbound jet. So if x is the speed of my eastbound jet, what is the speed of my westbound jet? That was the pink one, the one going west, or to my left, for those of you directionally challenged. Well, remember that it's going 50 miles an hour faster. So it's the same as x, but it's 50 faster. Goodness. So that's the same as x plus 50. So if I come back up here to this chart that I made, I'm going to end up putting my x as my rate for my eastbound, and I'm going to put x plus 1 as my westbound. Well, now I need to figure out time or distance. So let's come back down to my equation. D equals R times T. Let's look and see if I can find T, how much time I'm spending. Two jets leave Dallas at the same time, all right, and fly in opposite directions. One is flying west 50 miles an hour faster than the other. We've dealt with this part. After 2 hours, so how much time has elapsed? Right, 2 hours. That's the same whether they're going eastbound or westbound. They're both 2 hours apart. Okay, so I've got that. Now I need to see if I can find some distance. So my distance is my D. I have 2,500 miles apart as my distance. So now let's think about this. That doesn't mean that they are 2,500 from their starting place. It means that where they end up here and here is 2,500 miles apart. It's this whole distance from where this plane is and where this plane is. After 2 hours, they're this far apart. So how am I going to end up representing that? Well, if my distance equals 2,500 miles, and I know that d equals r times t, and I know that my r equals, for my westbound guy at least, like this is the westbound r, I'm sorry, eastbound, then this equals x, and I know that my blue t equals 2. So therefore, my blue d, I'm just going to plug these variables in up here. So I now take d, instead of r, I'm going to put x, and instead of t, I'm putting 2. So d equals x times 2. Or I could rewrite this as d equals 2x. So my distance up here in my blue is 2x, but that's also equal to 2,500 miles. Okay, well, how else, what is the distance for my pink guy? Well, it's not going to be that different, right? Like, distance still is 2,500 from this guy. Doesn't matter. This one's 2,000 from here, just like he is 2,000 from him. So distance equals 2,500 miles. D still equals r times t, and I know that my r equals x plus 50, and I know that my t equals, from my chart above, 2. So I'm going to plug this back into my equation, and I'm going to end up getting d equals x plus 50 times 2. Where did I get that? Well, x plus 50 is r, so I just plug x plus 50 in for r, and I plug 2 in for t, and I got x plus 50 times 2. Make sure to use your parentheses here because I'm saying the sum of x plus 50. The reason this is important is because I'm going to have to end up using the distributive property here, so it's 2x plus 100. That equals d. So this was 2x plus 50, which also, by the way, is 2,500. Okay, so now I need to get back to what I want to know. Ultimately, this question was wanting me to find the speed of each jet. Cool. So how do I find speed of each jet? Well, let's come back and look at my picture again. So remember that both of my jets started about here, and they took off at the same time. And my blue jet went this way. I'm sorry, I think I call this my pink one. No, I'm sorry, my blue one's going this way. So my blue one is going this way, and then my pink one is going this way. And so the total distance, this total 2,500, is the distance of my westbound jet plus the distance of my eastbound jet. That ends up equaling this 2,500. The 2,500 is this whole part. So I've got to look at this problem as a distance problem. So I have to set my distance of my westbound jet, add to that the distance of my eastbound jet, and then hopefully I will get this 2,500 because they're going in opposite directions. They're not going along the same path. So what is the distance of my west? Let's come back up to this chart we made. Well, the difference of my west was 2x, 2 times the sum of x plus 50. And then I'm going to add to that the distance of my eastbound, which is this 2x. And together those equal 2,500. So I think your book has this written differently. They just kind of rearranged it. It's just 2x plus 2 times x plus 50. And they had it set up this way for 2,500. It doesn't really matter. Well, now I've got to distribute this through, right? So I have this 2x plus 2x plus 100, and that still equals 2,500. And now I can combine like terms. Even though they're different colors, let's look at this. I have 2x plus 2x. They're both x's. So I have 4 x's plus 100 equals 2,500. Notice when they're going opposite directions, I had to add my 2d's. I couldn't set them up to each other because dw does not equal de. Well, it does, but I don't know what the distance is from this point to each. If I divided 2,500 in half, I could come up with it. But if I'm talking about the total distance, I have to add the distance of one plane plus the distance of the other when they're going opposite. So let's come down here and continue solving. I have 4x plus 100 minus 100 equals 2,500 minus 100. Because what I do to one side, I've got to also do to the other. These cross out and I'm left with 4x equals 2,400. Divide by 4. And hopefully you get x equals 600. Okay, so that gives me which distance. Is x the distance of my westbound or my eastbound? Well, let's come back up here to my chart. X up here is blue, so it's my westbound. So, I'm sorry, my eastbound. So my eastbound jet is going 600 miles per hour. How would I find the speed of my westbound jet? Well, my westbound jet is going x plus 50. And I know that x, based up here, is 600. So it's 600, and it's 50 more. So my westbound jet is going 650 miles per hour. All right, and then if I wanted to see how much distance each plane traveled, I could end up plugging it into my distance and rate and time formula. So if distance equals rate times time, and I want to see how far my WestJet went, distance equals the rate, or 650, times the t, or 2. And you're going to see that equals 1,300. And the distance for my blue jet is d equals 600 times 2. So this guy went 1,200 miles in 2 hours, and my pink one went 1,300 miles. Remember that the D's aren't the same because the rates are different. One plane is going faster than the other, and we're talking in the same time frame. So if I have 2 hours and I have 2 cars, one of whom's going faster, the faster car is going to go more miles. So remember, when you have opposite direction travel, you have to add the direction of one to the direction of your other item to your total miles. And then you have to plug your rate times time into your pink and add to it the rate times time of your other one. And again, keep that equal to miles. That's how you solve these problems. All right, go ahead and finish out your study guide. Your note-taking guide should be all completed at this point. And I will see you in class tomorrow for some more practice with these problems. Thank you and have a great night.